Today I will be teaching you how to memorize unit circle, or at least the way how I would like to do it. First we're going to start off some charts, and just real quick, I want to say that I wish I got this video out a bit sooner, because I feel like it would have helped more people, considering how it was finals week recently, not too long ago, but didn't get it out sooner, so sorry about that. Yeah, so we want to start off with some charts. We're going to use these for the numerator and the denominator of the units that we're going to use for around the circle. First, we'll start with our quadrants. So the top right quadrant will be positive, positive. Second quadrant will be negative, positive. Then it will go to negative, negative, and then positive, negative. And this will be helpful for assigning negative and positive values for the x and y values. But you'll see that. We'll see how we use that in a bit. I'll use this for something else in a bit. But let's start with our units. Now, we can start off with the 4 crucial units you have to know. I feel like everyone should know this by now. It's going to be 0 or 2 pi, depending on if you're at 0 degrees through 360. Then it's going to be pi over 2, pi, and 3 pi over 2. Okay, great. So why is it this? Why is it like this? Well, it's because we're going to start off with 0, and then we're going to go to 2 pi, kind of like a number line. And then we can divide this up. So this is pi. This is pi over 2. And this is 3 pi over 2. There you go. And then our units will come in between. So this here is like anything from pi over 6 to pi over 3. And then the pattern will be similar, so on and so forth. Okay, so let me just fix this up real quick. So you'll see other videos on YouTube on how to draw the unit circle. They just kind of write down the units around the circle with not really much thought as into like why it works and how do the different units correspond to each other. I guess I'll explain that in a bit, but I want to show you how I memorize the numbers first. So we're going to start with the denominator, and that's going to be 643 and 346. And it's going to be the same thing on the bottom here. Great, so this is an easy pattern to memorize. And then here it's going to be 111 top right and 5711 the bottom right. I just find this part of the these two quadrants easy to remember compared to the second and third. And then you're gonna have 532 here and 754. If this isn't easy to remember, just kind of imagine it's like you're going 2 and 1. So you drop 2 and then you go 1. And then you're gonna drop 2 and go 1 for 754. They're kind of like random numbers to memorize, but you're gonna see how I'm gonna use them, because we're gonna start with our first quadrant, and these two numbers will help with our numerator and denominator. So we're gonna have pi over 6, pi over 4, and pi over 3. What did I just do? I just applied the top value, which is 1, so 1 times pi, and the bottom value, which is the denominator, which is going to be 6 at first, right? Yes, right here, 6, and then 1, 4, and then 1, 3, and then 1. You kind of want to read the chart like you're reading from left to right, by the way, and also make sure to apply pi every single time, because pi will be a given throughout the entire circle. Okay, so we can also go from here to there. So you have 5, we have 6. So we're going to go 5 pi over 6. Great. Move over. We're going to do 3. We're going to do 4. So we're going to have 3 pi over 4. And you can kind of get the gist of what's going on here. Just reading the chart and assigning values. And you could do the same thing with the bottom here, but I won't because of time. and I want to teach you guys real quick. Okay, so let's move on to our radians. I did erase the numerator and denominators over here, but if you go back in the video, you can get it back. But I just want to have some more space. So I'm going to make a chart here for our x and y coordinates regarding the reference angles and the radians. Basically, if you go by the x place, or the x value, you'll notice a pattern where if it starts with 1/2, it's going to hug the y-axis. And then it's going to hug, root 3 over 2 is going to hug the x-axis. And this is just for the x value. I like to go by the x value, but you can have a better pattern for this if you want. So kind of think of it as increasing like this, where with the arrows here I'm showing. So what do I mean by this? Well, let me show you. When you have your radians for the x and y's, it's going to be either of these 3 different patterns. Great, and then from here on out you can apply your negative and positive signs depending on which quadrant you're in. But for the most part, you should memorize these coordinates, because it's basically the same thing, just different patterns with negative and positive signs throughout the unit circle. Oh, and also memorizing where root 2 over 2 and root 2 over 2 is going to be on the unit circle is easy to remember, because it's always just going to be at 45 degrees from either of these lines. Oh yeah, and do not forget to apply your positive and negative signs. So negative here, 2 negatives here, and then a negative here. Sorry if they're a bit small, but I don't have much space, and I don't really feel like erasing to fix it. Okay, great. So now we're gonna make a 5th secret chart, and this chart is mainly for memorizing a cool pattern. If you can't memorize the number technique I showed you earlier that I just erased, at least try to remember this. When you're in the first quadrant, all you have to memorize is just pi over 3, pi over 4, and pi over 6. And then from there on out, it's just memorizing whether or not you're going to be subtracting by pi, 2 pi, or just adding pi. So if you're in the third quadrant, you're going to... No, I'm sorry. If you're in the first quadrant, just have pi, right? Memorize these 3 numbers. When you're in the second quadrant, you're going to want to subtract by pi. And then when you're in the third quadrant, you want to add pi. When you're in the fourth quadrant, add 2 pi. Subtract 2 pi. What do I mean by this? Well, I'll be right back. I'm going to cut the video and I'm going to show you with the entire unit circle entirely filled out. Okay, and we are back. I made another circle and I made the same amount of slices and cuts. And this time I filled it out with the radians for x and y along our reference angles. And right now I want to show you the relationship between the angles, so it's not like we're memorizing random ass numbers off the top of our head. So just in case if the 2 charts from earlier we made regarding numerator and denominator don't make sense, I'll clarify that right now. This will be helpful for polar coordinates, by the way, if you do make it to Calculus 2, to all the pre-calc students out there. But basically, let's start off with an example here. So pi over 6, right? If we want to go to the, let's say the third quadrant here, we're just going to add pi to pi over 6, and we're going to go across from pi over 6. We're not going to go to 5 pi over 4 or 4 pi over 3 in the third quadrant. We just want to go to what is across from pi over 6 by 180 degrees, right? So 180 degrees, that's like a straight line, right? So if you add 180 to 0, you get 180, right? So no surprises here. We're just going to add pi, and in this case, pi is going to be 6 pi over 6, because we have to convert it by multiplying by 6 on the top and bottom, So you might want to look back to elementary school and how you added and subtracted and multiplied your fractions if you don't know how to do that. So in this case, it's going to be 6 pi over 6, and that's going to get you 7 pi over 6. And that's your answer. Now, let's see if the rules hold true to the other quadrants. So over here, it's going to be a bit different because we're going to be subtracting. Oh wait, here, let me fix a mistake on the chart. I'm going to subtract 2 pi for quadrant 4, not add. Glad I fixed that. Okay, so for quadrant 2, we're going to subtract 2 pi. Or no, we're going to subtract by just 1 pi. And we're going to do that by doing pi minus whatever you had in the first quadrant. So let's go with pi over 3. So in this case, it's going to be 3 pi over 3 minus pi over 3. And that will get us 2 pi over 3. And that is our answer. So that is how you find the radians for other quadrants. Okay, and we are back again. Okay, so now I'm going to show you how sine and cosine and also tangent applies to the unit circle. So let's say we have pi over 3. Okay, what can we do with that? If we had the sine of pi over 3, what would this equal? Well, all we have to do is just look at our trusty little unit circle, and we're going to look at our radians. And we're going to look specifically in the y place of the x and y coordinates. So we have root 3 over 2, and that is your answer. You just quickly look at the unit circle and you apply. Same thing with cosine. So let's say we had cosine pi over 3. Just do exactly the same thing. We have 1/2. So that would be 1/2. Now, what is tangent of pi over 3? Well, this time we're going to do tangent y over x. So that means we're going to take whatever sine equaled, and we're going to divide that by whatever cosine equaled. In this case, it's going to be root 3 over 2 divided by 1/2. And so, if you want to solve this, just multiply top and bottom by 2, and then that's going to leave you with just root 3. Because we multiplied by 2 to cancel out the bottom, which is 1/2. Okay, so this is root 3. I want to give you guys a bit more of a complicated example, so it's not just going to be the simple first quadrant doing all of the work. Let's go with something from quadrant 3. Let's say I want to find sine of 5 pi over 4. Okay, so same thing, apply the same strategies. So for 5 pi over 4, we're going to look all the way down here. This is our 5 pi over 4, by the way, if you can't tell, because I didn't really organize the radians so well, but this right here is 5 pi over 4. Okay, so we're going to have negative root 2 over 2. Great. Oh, whoops, don't need to put the parentheses. I just did it again. Crap. There we go. Oh, and it's the wrong one too. Whoops. I'm really not on the ball today. But it doesn't matter because this was also going to be root 2 over 2. And for tangent, do the exact same thing. Let me fix that parentheses. Great, so then we're going to multiply the top and bottom by 2. And then we are just left with negative root 2 over negative root 2. You could leave it like that. I bet your professor or teacher would let you keep it that way. But we can go above and beyond and just say it's just 1. Because the negatives will cancel out. And then we're just left with root 2 over 2. And anything divided by itself is just 1. And that should be your answer. Okay, so that's all I have for today. Not really much else to show, but this is a pretty helpful and effective way to memorize the unit circle, at least with the 2 techniques I just showed. And yeah, this is pretty helpful from pre-calculus to calculus 2 and maybe beyond, if you're doing something like multivariable or differential. I don't know if it ever does come back again, but it's handy to memorize it. Alright, thanks for watching.